Hello viewers, welcome to today's video lecture. Today's video lecture is all about general chemistry. It's all about general chemistry. From 11th and 12th we discussed about chemical reaction. We discussed about a chemical reaction. Chemical reaction, what happens? Basically chemical reaction, what happens? Reactants reacted to form products. That means what happens in this process? Breaking of bonds and forming of bond took place. Now the question arises, what is a bond, right? And from 11th and 12th we discussed about classification of bonds, right? Classification of bond. So various classifications like covalent bond, like coordinate bond, like ionic bond, like weak force, like a hydrogen bond, right? So these are various classification of bond, and we already have misconception that ionic bonds are stronger bonds, but actually it's not like that. Ionic bonds are not stronger bonds. According to thermal stability, this depend upon if thermal stability, so these are strongest bond, but actually it's not like that. You can't say this ionic bonds are strongest bond, right? Now broadly talk about covalent bond. We will discuss first what is covalency. When you talk about covalency, that means covalency means orbitals overlapping, like orbitals overlapping. Covalency depends upon the orbitals overlapping. This covalent bond, we focus on covalent bond because the covalent bonds are the most important classification of bond in physical chemistry, organic chemistry and inorganic chemistry. That's why we broadly discuss about the covalency. Covalency is the factors that depends upon the orbitals overlapping. Suppose I take two entities. Like that may be ions, that may be molecules, right? That may be atoms, right? So the two entities when comes closer, what happens at that time? What happens? The orbitals overlap. The extent of overlap depends upon the close proximity when they approach towards each other. Suppose this is an entity and this is another entity like A and B, right? Now they come closer. So what happens? They come closer and each having definite orbitals. So this A having this orbital and this B having this orbitals. When they come closer, this is orbitals interaction or orbital overlapping. So this is actually covalency. Covalency means you are discussing about the orbitals interaction or orbital overlapping. It doesn't depend upon how much extent you interact. It's only just depends upon if they interact or not. So that is broadly we talk about covalency. That means we are talking about a covalent bond, right? Now the question arises, we discussed what we discussed in present scenario. We talk about a chemical reaction. Chemical reaction means what? Chemical reaction means a bond breaking and a bond forming. The old bond and this is new bond. So bond is what? Bond is various classification like covalent, coordinate, ionic and weak hydrogen bond, right? Then we broadly discuss about covalent bond because in physical chemistry, organic chemistry, inorganic chemistry, covalent bond are most important bond factors of this classification of bonding. That's why we broadly discussed about covalency. Covalency means orbitals interaction or orbitals overlapping, right? It doesn't depend upon the extent of overlap. Just if they overlap, that depends upon the close proximity or close approach they come together, right? So we will broadly discuss about orbitals, right? So when we talk about orbitals, which is the basis of the bonding, because the topic we are going to discuss using this general chemistry is chemical bonding. This is one of the most important chapter while studying the chemistry, right? So orbitals, right? Now orbitals can be classified in two ways, right? Like classical and quantum, right? Quantum is a broad topic. We will discuss this quantum in individual entity, right? So now when you talk about classical, right, we discuss about energy, the energy of orbitals, the shape of orbitals, right, the size of orbital, right, penetrating power of orbitals, penetrating power, right, and the next is shielding power or shielding effect. And we are not discussing this one because it is another chapter, right? So now when we talk about orbitals, we need to think about its energy, its shape, size, penetrating power, shielding effect. And we know that basically the orbitals we study, there are 4 orbitals. Like, what are those orbitals we study? Like s orbital, p orbital, d orbital, and f orbitals. The question arises, only 4 orbitals we study or more than 4 orbitals? Yes, there is also g orbitals also there. So basically we focus only on 4 orbitals, that is our understudy. Now we will discuss about s orbital. We will discuss this various phenomenon of this classical mechanism, that is energy, shape, size, penetrating power, and shielding effect, one by one. Now we will discuss s orbital, right? Okay, from 11th and 12th, this is the basic topic. When we discuss about s orbital, we talk about its shape, we talk about its shape or geometry. It is spherical, it is spherical. Okay, suppose if I will draw like this, it's a 2D structure, but it's not like that, it's ring, it's not like a ring, it's like a sphere, it's like a sphere. If this sphere contains electrons, if this sphere contains electrons, so they will be distributed symmetrically, they will be distributed symmetrically. Suppose this is my nucleus, suppose this is my nucleus, right? Suppose this is my nucleus, and surrounding the nucleus, this is my center, and this surrounding the nucleus, so suppose this is a sphere, and this sphere means that is s orbital. So when I talk about s orbitals, the electrons are symmetrically distributed and the electrons are negatively charged, and the center, which is nucleus, is positively charged. So what happens? The negatively charged will be attracted towards the positively charged. That means what happens? From everywhere there is attraction. From everywhere there is attraction, and there is attraction symmetrically distributed. So what happens? The size contracts. Size contracts. Yes. Now we will discuss about p orbital. Similarly, we will discuss about p orbital. Right. When you talk about p orbital, you know that p orbital, the shape is dumbbell. The shape is dumbbell. You know that this is dumbbell type of shape, right? This dumbbell type of shape, right? Imagine in 3D. So this is a dumbbell type of shape, right? So each side represents a different lobe. Each side different lobe. But here there is no lobe because this is sphere and it contains 2 lobes. Similarly, we talk about d orbital. That is 2 lobes. We will discuss it broadly. Now similarly f orbitals also there. We will discuss in proceeding lectures this d orbital and f orbitals. Now we will basically discuss about penetrating effect. penetrating effect. Right. So what happens? Penetrating effect. Penetrating effect means what? Penetration. Penetration. Suppose this is a marker. Suppose I penetrate into a particular thing. That means it depends upon how sharpen it is. How sharpen it is. Suppose this is S orbital. Suppose this is P orbital. Like dumbbell type of shape. Suppose this is P orbital. Right? This is S orbital. Spherical. This is P. Right? So if this is a nucleus. So if this is a nucleus and suppose this is a sphere and suppose this is another sphere. Got my point? Now suppose I will take a nucleus and surrounding what happens? So this is a sphere and what happened? The surrounding, this is a orbital. This is an orbital, right? So this is sphere, this is orbital. Clear my point? Right. So now come to this one. Suppose this is 1s and suppose this is 2s, right? Suppose this is 1s orbital or 1s subshell, or this is 2s orbital or 2s subshell. Okay. So we will discuss about orbitals. We'll discuss about orbitals in vividly manner. Now we are using the term called subshell. Similarly, shell will come and final electron will come. Now I have to arrange it. I will come to this part later. Let me complete this one. Okay. So we discussed little bit about the basics of general chemistry like orbitals. Now the question arises: electrons. Where electron present? Electron present in definite orbitals, right? And orbitals are present in definite subshells, and subshells are present in shells or orbit. Shells or orbit, right? Now remember those terms like principal quantum number. Those terms like principal quantum number. Principal quantum number, right? We represented this principal quantum number as n, right? For n value 1, for n value 2, for n value 3, n value 4, you designate this 1, 2, 3, 4 respectively for different or definite number to this one is K shell. The shell name is K. Shell or orbit is K. Orbit, right? This is L shell or L orbit. The corresponding principal quantum number is 2. And this is M and this is N. Clear this point? K, L, M, N. Now the question arises: only 4 quantum numbers or more than 4 quantum numbers? Yes, more than 4 quantum numbers are there, but we broadly discuss about K, L, M, N. O also there, P also there. Similarly, when you discussed about orbitals, we focused on only 4 orbitals like S orbital, P orbital, D orbital and F orbitals, right? What we discuss right now, we discuss about electrons. Electrons are present in definite orbitals. Orbitals are present in definite subshell and subshells are present in shells. And we discussed about principal quantum number. We discussed about principal quantum number represented by symbol n for n value 1, for n value 2, n value 3, n value 4. The shell or orbit is K, L, M and N. Right? K, L, M and N. Next we'll discuss about the definite orbitals. The definite orbitals. Okay, before that I am going to give you another example. Another example. Right? Suppose I talk about sodium element. Suppose I talk about sodium element. Right? The sodium element, how many electrons it is having? 23, or you can write like this. This represent atomic number and this represent mass, atomic mass, right? So you know that this is neutral, there is no positive charge or there is no negative charge. That means there is no charge mentioned here, that is it is neutral. When this is neutral, the number of protons is determined by the atomic number. So here number of protons is equal to 11, and since this is neutral, number of electrons are 11, right? Now the question arises, how we will arrange these electrons? Now you know that this is neutral, 11 protons and 11 electrons, positive charge, 11 positive charge and 11 negative charge cancels each other and it makes charge neutral, right? And we discuss about the sodium element, its atomic structure. Its atomic structure, how the atomic structure will be defined for the sodium element, right? See this on the board, please be attentive. You see this one, this is a nucleus. The center of an element is known as nucleus, and this nucleus contains the protons and this nucleus contains neutrons. Nucleus contains protons and nucleus contains neutrons. The protons are positively charged, neutrons are neutral and electrons are negative charged. And you have to remember that the nucleus is positively charged, and surrounding the nucleus electrons are revolving in definite shell or definite orbit. These orbit or shells are known as K shell, L shell, M shell or N shell. So but this is my nucleus, and surrounding the nucleus there is circular path, there is another circular path, there is another circular path, there is another circular path. So if this is my nucleus, the first orbit where the electron revolved around the nucleus, where the electrons revolve around the nucleus is known as K shell or K orbit, right? Where the principal quantum number value is 1, that is n is equal to 1. The second shell is known as L shell. The third shell is known as M shell, and the fourth is known as N shell. And I already discussed O shell also there, P shell also there. But we broadly discussed about principal quantum number 1, 2, 3, 4. That is K, L, M, N. Now the question arises, where electron present? Already I discussed electron present in definite. Electrons are present in definite orbital. Now the question arises, where we will discuss about orbitals. Now we will discuss about orbitals. Look, there is electrons there. I already told you that electrons revolve in a circular orbit or shell around a nucleus, right? Now the question arises, how many electrons it will revolve? Now if this is sodium, and you know that the center contains 11 protons. The center contains 11 protons. Now the question arises, is there any neutrons? Yes, there is neutrons. Look here, sodium atomic number 11 and the atomic mass of sodium is 23. Okay, and you know that number of protons determined by this atomic number, and the number of protons are 11, number of electrons are 11, because this is neutral, no charge mentioned here, this is neutral, and the number of neutrons is defined by atomic mass minus atomic number. So here you subtract this atomic mass